Good day, dear colleagues. Yes, my name is Alexandra. I am a technical support engineer. And today, during this masterclass, we will get acquainted with the LIRA SAPR program. Wait a minute, please. I will show you my screen. And we will get acquainted with the LIRA SAPR program and some of its systems. Within 40 minutes, we will create this model and using the generator systems, see the main functions of SAPFIR preprocessor and perform the analysis of the model. If you will have some questions during my presentation, you can ask them through microphone in the end, or you can write them down in chat at any time. So I will close. We will start from this sketch. Usual, every project we recommend to start from setting up building codes for the project and the project properties. It's a building code for loads, so I will choose SPR-KEN. It is adapted for Kazakhstan, but contains all the combinatorics that is inherent in the Eurocode. And also you can specify here the properties for design analysis, for example, for analysis of reinforced concrete or masonry structures or steel structures. Also in this dialog box, you can specify the safety factors that will, for combinations that will be necessary for analysis. The default settings which will be loaded at every start of the program, you can specify here in SAPFIR preferences. My project already has a basis from lines. It's just simple lines. They were created using tool line with these methods of creation. And also I have in this project grid lines. Here it is. And these grid lines were created using this dialog box. I add the interval, specify the distance between vertical grid lines, and the same for the horizontal one. So, and we will start for the first step. We will create columns on the grid using the generator system. The generator system is a visual programming system. Visual programming not only helps to save time when creating a model, but also significantly reduces the time and labor costs for project adjustments. So here you can see different tabs with nodes. We will start from the geometry tab, and we want to create points on the intersection of grid lines. So I select this node, put it on the canvas by right click of mouse button, then select this grid line and add it to the input of this node. To add objects to the input, you should right click on the input and select a command add objects from the shortcut menu. The important thing that the record of this master class will be available and also I will give you the materials necessary so you can repeat all my actions in your computer, on your desktop. So we have added the grid lines, and now we can see such red points in the intersection of grid lines. We can create columns on the base of these points. So I select the node columns from the tab models and connect the output P from the grid lines to the input P from the columns. Important note that the designations of inputs and outputs gives us a tip what data we can specify here. So it can be points, vectors, lines, and so on. Here our columns were created on the grid lines. The advantage of the generator system is that when I will edit the grid lines, the distance between them, my columns will move with the grid lines. I'll press undo several times to return for the initial position. And now maybe we don't need such amount of columns. So let's see how we can control what points to generate, what columns to generate. And let's select node, this one, cut points outside contour. I will add it to the screen, to the canvas. Then I will delete this link. So I will select it, press del button on the keyboard, and then connect through this node. Nothing has changed, but we need to specify the contours inside of which and outside of which the columns will cut off. So I will select this inside contour, inner, and add it to the input inner line. So add object, you can see that the columns from inside were cut off. And similar operation for the outside contour, also add objects. If I will move these contours, the columns will be created, or the columns will be eliminated. So it depends from your actions, and it shows us that this system is such parametrical with graphical editing. The next, we can specify the properties for the object that were created in such a way. So I will select this node, and here in its properties, we can see that it has default material, RC columns. I will tell you about materials in SAPFIR a little bit later. And it has default section 400 on 400, rectangular. It's okay for us. And also we need to specify a property necessary for analysis. It is called generate perfectly rigid body. We will select the option yes, press OK. It means that on slab above the column, the program will create the perfectly rigid body. It has the undeformed region without bending moments and reinforcement. So it is a necessary option for analysis. Also, it should be mentioned that when we select the analytical representation, you can see that we have created not only columns in its physical representation, but also its analytical model. So it's a bar for analysis. And let's move, let's go on. Now we have to create walls for our building. We can create different objects on the base of one line. So we have here blue lines. I will create walls for these blue lines. And if we want to use this object one more time, we will use it for openings and slabs. You can add them to the so-called container. I'm sorry. To the so-called container. So I should select them, but I can do it because I select the grid lines. So we need to use the filter for selection. Here it is on the toolbar, filter to select object. I will open it. Here we'll disable all check and select only line, press OK. Now I can select our blue lines. To select few objects, you should press Shift button on the keyboard and then add them to the this set of lines. This set of lines, it's a so-called container. It does nothing with the objects. It just stores data. So, for example, it stores data for walls and for openings. So the next, I will create a link between node set of lines and node walls. And also I will add this yellow line. We will not use it again in the project, so I can add it directly to the input ln for walls. So I select add objects. And also you can see that we have analytical model So not only physical, but also analytical model for our walls. The parameters, the default parameters for walls for us is okay. It is the material RC walls and thickness 200 millimeters. Also, I should tell you that if we want to edit the geometry of the walls, I can't do it directly. So I should select, I'm sorry. So I should select the line and edit the line geometry. And the wall will also edit it. I will come back to our project, but if I'll return all the objects in the filter. If we want to edit wall, I can do it because its geometry depends on line. Also for columns, I can't edit it directly. I can edit it through the moving of grid lines. It's an important moment that you should keep in mind while you are working with the generator system. The next step for us is to create a shape for our building. We have such a vertical line. It will be a trajectory and form a shape of our building, rectangle. It will be a generatrix. So I will select the surface, kinematic surface by specified trajectories and generatrices and add it to the canvas. Now I select this vertical line. To create vertical line in SAPFIR, you should use these commands. Use a coordinate system along X and Y. These commands rotate the user coordinate system. And also you can use the hotkeys Alt-X or Alt-Y. So I will add this trajectory to the input trajectory 1. And this generatrix to the input generatrix 1. The program have created a surface for us, and now we should specify the properties for this surface. So I will select it in the model. Here I should specify the material. It is undefined, so I will open the dialog box materials. Here on this tab, we have materials that are represented in project. And on the general tab, you have all materials that from SAPFIR library. I can select here glass and press OK. The next, I should specify number of parts in trajectory, it's 45. And number of parts in generatrix, it's 48. And the twisting angle for our surface is 96 degrees. So here it is, our surface that will be the shape for our building. The next step is to create floor slabs for this shape. On each story, the floor slab will have an individual configuration. So if I will create it manually, it will take a lot of time. Therefore, we also will use node. But we need to know at what levels to create floor slabs. So I need stories. And some certain heights for these stories. The stories can also be created with the help of generator system. Here we have 2 nodes for it, but I will create them in the old way through the project structure. So I will select a command new story, specify here number of stories 15, and press OK. So I have 16 stories. Also, my columns multi-copied by these stories. We will return to this property further. I will tell you about it. And so I will select the first story. And now we need slabs. So on the tab models, I will select the node slab. We'll put it on a canvas. And here I also need some lines from intersection of our shape of building with the levels of stories. Here it is, this node it obtains lines of intersection between surface and planes. So I can connect this output surface to this input surface, and on the tab geometry, panel plane, I will select node obtain planes at story level. We'll put it here on the canvas and obtain planes from the levels of my story. So I will connect this node to the input plane. We can see such red lines across my surface. So now I can connect this output ln to the input ln for slabs. I will do it. So we can see that the program have created slabs for us on the levels of stories. Also important point is that by editing the shape of this, surface, so I will edit line, we see that our slabs also change its form. So the generator system, the objects in generator system are very dependable. They depend on each other, and it is very convenient to edit their geometry. Well, but mostly we do not need all the same slabs on the model. For example, the foundation slab or the cover slab may differ. So to create objects not for all lines, but only for some of them, we will use the filter node. Here it is. It is called filter elements in the list according to defined parameter. I will put it here. We'll delete this link and we'll connect through this node. In this node, I will specify the mode is exclude, so we will forbid number at the beginning 1. I will specify, so we will forbid the creation of the first slab because this slab will be of another material, from another material with another thickness. So now I will specify this foundation slab. I create one more node filter and one more node slab. Here in this filter, I specify the mode. On the previous node, the mode was exclude. Now it will be allow. Number at the beginning 1. And I will connect this node to this slab. So, and for this slab, I will specify that slab type, it is not floor slab, but foundation slab. The thickness of it is 800 millimeters. Then it is, I also want to specify overhang, it is 1000 millimeters. Okay. And the next step, we will create openings for our slabs. So I can also do it with the help of nodes. In the first tab models, I can select this whole slab, put it on the canvas. Now we remember that we have two contours at 0 elevation, and from these contours I can take from this set of lines I can take the lines for the holes in our slab. Now I should specify in what slabs to create the holes. So I will create a link between slab output to the slab input. So, and we don't see our openings because I will hide this surface. I think it will be a little bit more convenient if I will hide it. So because our contours are at 0 elevations and our slabs are at elevations 3 meters, 6, 9 and above. So I should multi-copy these openings in the properties of this node. I select the node opening, then in its properties, multi-copy by stories, I select option yes, and stories we have, you can see that openings were created in all stories, but I don't want this. I want to create openings at specified stories, and here I should disable the option story number 16 because I will consider it as a roof. So in such a way, we can control at what stories to create objects and at what do not create objects. Let's perform the similar operation for column node. Here we have multi-copy by stories. Here I also will specify that I don't want columns on the 16 stories. So you can see that our columns have eliminated. And the similar I will do with the walls. I also will select option multi-copy and without 16 stories. Okay. Next, we need to create, I will show our, with the help of this button, you can show all hidden elements, and with the help of these buttons, you can hide selected or show only selected, for example. Then we need to create bar elements along the surface in each corner. We can do it with the help of this node. It helps us to obtain lines from the surface. So I will select it, put it on the screen. Here we'll connect the surf node to this input. And we see that the program have created the lines across our surface, the horizontal lines. It is the output ln1, and also the program have created the lines along surface. It's the so-called vertical one. It is the output ln2. We need this output ln2. We will create bars at these corners. Universal bar in SAPFIR, it is a beam tool, so I will add a node beam to the canvas. And now I want to create, I don't want to create every beam on every line. I want to use filter to create beams only in corners. So as you remember, in the properties of this surface, I have specified number of parts in generatrix 48. We have 4 sides, so 48 divided by 4. It is every 12th line. It is placed in the corner. So in the filter, I can, for mode, I should select allow, press OK, then list of numbers. Here in the bottom of properties dialog box, you can see the tooltip for every selected command, every selected option. So for list of numbers, I can specify indexes and divide them with spaces. So the indexes will be 0, 12, 12, 24, and 36. Press enter, then connect the output ln2 to this input. And now if I double click on the node, you can see the program highlight the object that goes from this output. So we can see our 4 lines. Also, I should tell you that as a generator system is a visual programming system, so all numbers, all indexes here start with the number 0, as usual in programming. This needs to be kept in mind while working with generator. And also I can specify if you want to see the number of elements, you can select node, and here in his properties, it is element number property. So you can press here option yes, press OK. And now if I double click this node, here on the bottom, I can see the indexes for lines. So here is the beginning, so 0, 1, 2, 3, and so on, and in vertical direction 0, 1, 2, 3, and so on. This comment is presented in every node, so you can turn it on and see the indexes if you want to use the filter node. And after that, yeah, I can connect the output list with the input LN for creation of beams or so-called universal rods for the corners of our building. Oh, yeah, we can see our building in analytical model. So it looks like that. This generated within 20 minutes, I think. And the next moment, we will focus on the materials for analysis. I also remind you, if you want that the tools in Generator allow you not only to create tunnel, but also to effectively manage it and, if necessary, make adjustments. And about materials. So here is the dialog box materials. We have default materials for each object in SAPFIR. The default material is specified here in SAPFIR settings dialog box. Here is there is a tab, default parameters for elements, and here you can see material for walls, it is RC walls, then default material for slabs, RC slabs, for foundation, RC foundation, and so on. One moment, I think that I have forgot to change the material for our foundation slab. Yeah, it is. It was RC slab, and I want RC foundation. Okay, and another important point that if you select material in the materials dialog box, you can see its properties. So it's some surface colors, priority. Imported for analysis is Young modulus, so it is used for strength analysis in linear statement, and also unit weight. It is used for the lowercase dead weight. The program automatically create a lowercase dead weight for the object if you specified a material for them and specify a unit weight for this material. You can create your custom material and specify these two parameters, and the program will work with them. Then important property is category of material. It is reinforced concrete. Here we have categories, metal structures, masonry structures. If category is reinforced concrete, it means that design parameters will be shown for reinforced concrete analysis. And here we can see the building code that we have selected for analysis of reinforced concrete. And if we press these three buttons opposite to this building code, we can see the material properties for analysis of RC structures. Here we specify the type of the object, column, beam, pile, wall, slab, or foundation slab, specify the properties for design analysis, for example, distance to center of gravity of reinforcement, spacing of rebars, the width of cracks, and so on. Also here, there is parameters for concrete, the class of concrete, and other factors, and for reinforcement. We will use in our project default materials, but you can also create custom SAPFIR material and also custom parameters for your project. Then we press OK. And the next moment is to assign loads in our model. As I have already said, the program automatically creates dead weight. So I open the lowercase editor by pressing this button on the toolbar. Here you can see dead weight load case, and another load cases are empty. You can see the number of loads here in this column. So we need to specify the loads on slabs. We can do it also through node. I will select all my floor slabs with roofing, and here in the properties of slab I can specify 3 values of load. For example, let it be 0.2, it will be dead load, then 0.2 live load, and short term let it be 0.1. So after I press enter on the keyboard, I can see the load case to which this load will be assigned. So for that load, it will be that load case, but you can select another one if you want, if you wish it. Then the load case for live loads and for short-term loads on slabs. Okay, you can see these loads. I will turn off the nodes checker. It will turn off these red lines and points. Red lines and points is the result of nodes working. So I will turn them off. And you can see here is short-term load on slabs. This is filter by load cases. You can press it and then live loads on slabs and dead loads on slabs. Well, also SAPFIR allows you to create another types of loads. It is concentrated loads, moments, distributed moments, linear load, even ice load. So also surface load. And a little bit further, I will tell you about wind and snow and earthquake. So surface load, you can create in the model. I should mention that the model creation is very similar to Revit. So if you don't use the generator system, you can remember the creation principles from Revit and create model in SAPFIR very easy. About surface load, if you want to create it with the generator, I recommend to do it so because it's very convenient. I select the load as area load from the model step and put it on the canvas. Here we have one counter, one left unused counter on the first story. Select it and put it added to the input ln from surface load. So add objects. Here in the properties of this node, I can specify the value. Let it be 0.5 ton forces per square meters. And the load case, it is load case without name, just load case. Okay, it also suits to our purpose. And now I can connect to the input slab the slabs, for example, these slabs. And I also should select the property multi-copy by stories in this node. And in the property stories, I don't want the load on the 16th story. Okay. So here we can see our load on each story. Also the important node. Also the important note is that I can edit. A minute, I will turn on only this load case, so I can edit the contour of load, and it is edited on each story. It's very convenient because, as you know, in every scheme you have a lot of loads, and when you edit one, you can forget to edit another. So here, all these objects are connected with this node. So I can, if you change the value here, or the load case here, or the country here, all these objects will change. And also, it is very useful when I connect this load to slab. I can change the, for example, the elevation of slab. I will add extra 50 millimeters to it, and we see that our loads move with slab because they are connected. So it is also very convenient for the scheme. Well, let's turn now our attention to load editor. So I will open this load editor, and here we can see the building code that we have specified at the beginning. Then our load cases, that is dead weight, dead loads on slabs, live loads on slabs, short-term loads on slab. These three values we have specified in the properties of slab. The load case that we have specified with the help of this node. And here in the we select the load case type, specify its subtype. In this dialog box, you can also create combinatorics, so mutually exclusive integration, accompanying, and sign alternation if you need. Combinations are created on the base of combinations rules. Here you can see these combination rules in this dialog box. So you can see safety factors, combination factors, and in the bottom you can see the load combinations, and here are the formulas according to which these load combinations are created. The formulas are from building code. Okay, but we will specify even three more loads. For example, it will be a wind load. SAPFIR program automatically creates wind load for your project. Here you can specify load case name, level if your building is have some depths or some underground stories. Width of structure is outer width is perpendicular to the wind direction. Apply to, this is interesting option, we will select apply to ends of floor slabs because we have scheme with columns and slabs, but if you have scheme with load bearing walls, you can select positive, negative wind pressure. The third option, apply to bars, it's actually mostly for masts, towers, and so on, so for metal structures. And define manually if you want to define wind manually. Then I will select option to represent the loads in architectural model. Here is the building code. You can select, let it be also SPR car EN. Wind region is the third one. Terrain category, let it be the third one. Constructional coefficient you can specify, and aerodynamic coefficient 1.3. It's actually 0.3. It's actually the sum of dynamic coefficients. So it's 0.8 plus 0.5. So we will create wind load. The program automatically takes into account the height of the building, so it calculates the load distribution along the height, the lower value, the bigger values. So here, these values, you can also change them in the, because it's usual linear loads, you can change them in the properties, or if you want, you can change the wind parameters. The program also have created load case wind and specify for its variable load case type and subtype wind. That's okay for us. Then I will. Then you should create another wind in the direction. It was angle relative to x-axis. It was 0 angle. You should specify another wind with the angle 90 degrees, and it will be wind y. But I will not stop in this because we have a lot to do, but not so much time. Then I want to tell you a little bit about snow mount, but at first I could show you how to create the walls with the interpretation load. So you can specify the thickness of this wall. I select the partition tool, but it means just that it is not non-load bearing wall. It's not only partition, it can be the exterior walls also. And let it be the parapet for our roofing. So the bottom elevation of the wall is 0 from the story level, and the upper elevation, it is 1,200 millimeters. Here in an analytical model, I will specify such parapet. You can see it here in the physical model. And in analytical model, the program have created a load case. It is called loads from walls. Let it be not variable, but dead. Okay, and I will press the filter only for these loads. So load from walls. The program know the material, so it is ceramic brick. For this material, the program knows the unit weight. Also, the program know the thickness of the wall, the height of the wall. So it has calculated the intensity, the value for our linear load. It is also a very useful property, and you can do this with all your custom materials. And now on the last story, I will create the snow mount. We have such snow calculator. Also, I will select it to SAPFIR snow region, let it be the sort. The height of parapet is 1.2 meters. Yes, I have specified it. I have just specified it. Coefficients, the sum of coefficients CE by CT. And a snow load near parapet, the program have calculated, and the snow load distance P, that is equal to 2H, is 0.147. Okay, so I can create this snow mount. Yes, help of chain. So there is our snow mount, and in the middle of this roof, I also want to fill it with snow load. So I will, in the properties of the snow mount, I will select the option fill it with snow load. Yes. In the load case editor, the program have created load case snow. It is variable subtype snow. Okay, and here in analytical model, we can see this snow, and the values near the parapet is bigger than the values in the middle of the roof. So, and the next one is the earthquake load. We can also create this in automatic mode. So here, parameters of dynamic load, we can specify the name for this load case, earthquake along X. So angle will be 0. Number of mode shapes, let it be 10. Then you building code, you have to specify building code parameters according to this building code, and the program in automatic mode have collect masses for dynamic load. So with conversion coefficient, it is equal to 1 for dead load cases and to 0.3 for variable load cases. Also, it's okay for us. We press the button create, and we obtain the earthquake load in the properties of our project. Here is our wind load, earthquake load, and also here in the loaded case, you can see the one more load, earthquake, and the subtype for it. Also, the program set the mutual exclusion for wind load and earthquake load. So after that, we should go to the DCL tab and press the, I will just select, let the live loads on slab be the leading one. So for the tab DCL, you can press the generate button and the program will generate for you the design combination of loads. So, okay. And the last stop, I think that it is the last stop to create boundary conditions for our foundation slab. We can import in SAPFIR. Actually, we can import DFC, the XF DVG file, but also the soil model we can import here. But today we will specify for our foundation slab just C1 and C2 coefficients, so modulus for subgrade directions, let it be 200 and 2K. Then CX and Y is horizontal stiffness of slab to soil support. So as we have horizontal load, we also should specify horizontal stiffness. We can define it numerically or parametrically. I will choose these options. Friction coefficient, it is for reinforced concrete with soil, it's equal to 0.3. And D, it is the allowable static friction deformation in direction of global x-axis. It's usually the small value, it can be 1 or 2 millimeters. Then you can create, for option create not more than 50 stiffnesses. I will select 10. Okay, and I will draw your attention to this parameter P vertical load, PZ. It is defined as property for foundation slab, and we should also specify this PZ. I will open this dialog box, and here can define it numerically, but I will choose the option define as design combination of loads and will create this design combination. So it is one. I will take all the dead loads and all variable loads. So short term and load case. I will not loads from all walls also, let it be 1. So I will not take for the vertical load on soil, the horizontal load case. Okay. Well, that's it. And now we can create, we can see our analytical model with loads, and we can create the meshed model for our beam model. So I will press OK. And what I want to say here, that all these elements are separate, they are not connected with each other. In analysis, all such elements will behave individually. In order for all the elements to behave together, it is necessary to intersect them with this command, find intersection, yes. So we can see the result of intersection. I will select the dead weight and press the filter button. The result of intersection is such, here is a perfectly rigid body on the slab from the cross section of our column, and the result of intersection is such purple lines. After that, we should specify options for triangulation. So here we have 3 types of triangulations: triangular, with the regular triangles, adaptive quadrilateral. It means that the program will create the regular rectangles along the supports, and then in the span you can obtain some triangles. And the quadrilateral, it is the opposite type of triangulation. It starts from the span, it creates regular rectangles in span, and then on above supports you can obtain some triangles. So I recommend to use adaptive quadrilateral. Select the step is let it be 0.3 meters, and smooth mesh. I also activate this option because it helps you to enhance triangulation to better quality. Press apply, and after that press the command generate mesh. It will take some time. Here we have our model with generated mesh. And here we have also some useful commands, useful mosaic plots. For example, distance to support. It shows the distance to support, and if we have some elements that is not connected to others, it also shows it in red color, so you can understand if your model is okay or not. Then it is the quality of place. It is the values between 0 to 1. Then also useful command mosaic plots for linear loads. You can see it, for example, for wind. So you can see the loads in such color representation with mosaic plots. And now I will press the open button and will save our scheme for LIRA SAPR module for analysis. Here, our scheme have opened in the LIRA SAPR module. I will open the flex of drawing and will select some commands to change the graphical representation of the model. For example, I would select stiffness and color. Then on the third tab, I select display with a count of assigned sections. And another command, I want to hide nodes. I will select redraw. So we can see our model with assigned section in 3D in SAPFIR or in LIRA SAPR module. We can check here is the first load case dead weight, then dead load cases on slab, short term, the load case with our surface load. You can see its value with the help of mosaic plots of loads. So you can open this dialog box, select across area, along that, apply, and you can see the values. Also, for example, you can see these values for snow and, for example, for wind, but you should change that it is distributed along lengths and for X direction, so you can also see how the wind load is applied to our building. Okay, so and also for the earthquake load, we can see that masses are taken from load cases, and here what load cases were used. Then on the analysis tab, you can see table of dynamic load cases and parameters that we have specified in SAPFIR preprocessor, the DCL table that we have created in SAPFIR preprocessor. And also here it is material properties. We have our stiffnesses that were calculated from the material and the thickness of elements if we talk about slabs or walls, and or cross section if we talk about columns or beams. And we have some numerical finite element 56 in the foundation that represent the horizontal stiffness of the horizontal stiffness of slab to soil support. Then we will go to analysis tab and select the button complete analysis to analyze our scheme. So it will take several minutes. So if you have some questions, you can ask them. I will gladly answer. Okay, so you can write them down, or you can even after masterclass send them to Daria or to our support email. I just want to mention that here in Generator, you can also not only create model, but you can also connect with the, for example, some GXF, and the program have provided the static analysis and start the design analysis have performed. Here you can have nodes import the XF or DVG that allows you to connect with dynamic, to have a dynamic connection with layouts. Also, we have such a renewable node for IFC. So if you have changes in IFC, you can, in this node, press the button, update model, and all changes from IFC will, you can see in SAPFIR, and also SAPFIR will highlight the object that have changed, for example, the new object or the deleted object, or the one that have moved, or if their properties have changed. We can also connect to Excel files and to SAF. It is structural analysis format, so it's also so-called new one for connection with ArchiCAD, for example, or Allplan. I think that our design scheme have calculated. So on the results tab, I will turn off the loads in the flex of drawing, and now we can see the mosaic contour plots on different direction. For different load cases, you can change them here. Next, you can see forces in bars, longitudinal forces and moments. Also, you can see stresses for our scheme. And for example, for earthquake load, you can see mode shapes. So you can see the forward shapes. The first one, the second one, I think also will be forward shape, and the third one will be, yes, the twisting one. What about analysis? You can analyze the reinforcement. The program have, you can evaluate the reinforcement. The program perform the design analysis. So it is upper reinforcement along X, along Y, lower reinforcement along X and Y, and reinforcement for bars. For example, symmetric, here is the percentage of reinforcement, or you can select the total reinforcement and some of the directions, and the asymmetric one. Well, also you can analyze all the properties, all the results in graphical representation, but also with the help of tables of results. So you can generate tables for reinforced concrete analysis, for forces, for stresses, for different elements. So we have a wide range of tools for this. Well, I think that's all for this masterclass. It takes a little bit more time that I thought, but within this I think maybe 55 minutes, we have created parametric beam model. We can dynamically edit for new project adjustments or requirements, and we have analyzed this model and have the first results for it.